Okay, guys, let's get started, guys. Okay, I started recording. Let's do just a couple problems. I'm not going to do every single one with you guys, but I'll just do what I think is going to be most useful to you guys. You'll have a couple exponential equations, so things that look like this. All right, how did we solve questions that look like this? Okay, good. Get the same base. So then this is going to become 6 to the 2 minus 2v, and then what does 216 become? 6 to the power of 3. Nice, guys. All right, and then you can cross out the same base, and then you get 2 minus 2v equals 3. Subtract 2 on both sides, and then you get negative 2v equals 1. Divide both sides by negative 2, and then you get v is negative 1/2. So once you get the same base and you cross out, it just becomes a normal linear equation, right? Shouldn't be anything too crazy. I'll try the exact same thing with the next problem. Again, I'm not going to do too many of these. You had a lot of these on your quiz. So I think just one more should be fine, right? Again, same thing here. If it's a fraction, what do you do to make it not a fraction? Good, make it a negative exponent. So it's going to become 5 to what power? Negative 4, right? And then you can cross out the same base. And then we get negative 2a. Wait, sorry. It's just 2a, sorry. 2a equals negative 4. Divide both sides by 2, and then you get a equals negative 2. I'm going to go in order. All right? Good with that one? Yeah. Anything else here that we want to go over in this first section? Yeah, hopefully everything is okay, right? I think everything kind of follows the same kind of ideas, right? So let's try this one now. These just say to evaluate the logarithm. Your answer is just going to be a number. So this one in particular, if you don't see a base, what do we assume it is? 10, right? So this is going to be log with a base of 10. What you're asking when solving these kinds of problems is what exponent do you need over 10 to get 10,000? What exponent is that? 10 to what power is 10,000? 4, right? So that's how you can think of it kind of quickly. Sometimes you'll get a base that isn't so easy to think about in that way. So what you can do, let me erase that. Let's just say you didn't know how to do that. Is set it equal to a number x, right? Let's just set it equal to x. And then when it looks like this, what's one thing that we can do to make it a little bit easier to solve? Good, right? So raise 10 to the power of x equal to 10,000. All right? And then from here, you can see that 10 to the power of x is the same as 10 to the power of 4. And then you can just cross out the bases, and then you get x equals 4. You don't need x equals for these. I mean, these are just going to get you a number. So shouldn't be too bad. Yeah, I mean, that's fine. You can just, yeah, x equals or the number. Don't really care. Okay, what about ln e to the 1/4? What happens with ln and e? Okay, very good. So you guys should know by now that ln and e are inverses. So this is very simply just going to be what? 1/4. It's just whatever you get after you cross them out. I want to show you guys that another equivalent way to write this is e to the power of ln to the 1/4. Do you guys see that? That's the exact same thing, just written a little differently. Do we see that e and ln still cancel out? This is just going to get you 1/4 again. So whether it's e to the power of ln or ln of e, you get the same thing. You could just cross them out. All right. Another thing that you guys should be aware of is log and 10 are inverses. What if it was log of 10 to the 2/3? Yeah, because log and 10 cancel out. Why do they cancel out? What's the base of log? Good, right? 10. All right. Similarly, if I have 10 to the power of log of 2/3 and I don't see a base, same thing, right? You could just cross out 10 and log, and that's going to get you 2/3. All right. Similar story with any base, right? If I have 7 to the log base 7 of, I don't know, 4x, what does that get you? Good. The 7 and the log 7 cancel. So you're left with what? 4x, right? So things that are going to make some problems super easy. I failed to mention this before, but your test is 14 questions. 14 questions. You're going to have a couple graphs and a couple problems like this that are just evaluate the log, right? And they shouldn't be anything super crazy, right? If you know properties of logs, it should honestly go pretty smoothly. Anything on this page that we want to go over? No, I think everything should be okay. All right, so now let's look at this page. What did I highlight? Okay, maybe something like this, right? Log base 7 of 343. Again, you can set this equal to a number x and then convert it. If you know the answer right away, that's also perfectly fine. But most of you, I think better in terms of exponents. So I get 7 to the x is 343. So how would I write this with a base of 7? To the third, right? And then these bases cancel and you get x equals 3. There's a lot of perfect cubes that show up over and over again. 343 is one of them. All right. And we can keep going. Ln of e, what does that get you? 1, right? That's one of our properties. Look at the one above it. Ln of 1, what does that get you? 0, right? And what makes it 0 is the 1 on the inside, right? If you had log of 1, that's also 0. If I had log base pi of 1, that's also 0. It doesn't matter what the base is. As long as 1's on the inside, it's always 0. All right. Lastly, let's try number 16. Again, I don't see a base here, so what am I going to write there? 10, right? And I can set this equal to x, and then you can convert it to exponential. So we get 10 to the x equals 1 over 1,000. How can I rewrite 1 over 1,000 to be 10 to the power of something? To the negative 3, right? Good. Bless you. To the negative third is also fine, right? So then you can cross these out, and then you get x equals negative 3. All right, so far so good. Hard, easy. Should be pretty easy, right? So these are ones that shouldn't take too much time, right? I know it's 14 questions, but that doesn't mean all of them are going to take an outrageous amount of time. These should be fairly quick. What might take a little bit more time are graphs. What's left on this page, I'll do number 17. And then I'll do one other graph on the next page, and that should cover everything that you'll see on the test. I'll tell you what to skip. There's a couple of things that we won't test you on. Okay, so it says domain and range, but I told you guys in class I'm going to want everything. So I'm going to want the vertical asymptote, the x-intercept, and the domain and the range. How would we find a vertical asymptote? Good, set the parentheses equal to 0. So x minus 1 equals 0. What do we get for x? X equals 1, right? And you want the x equals there. I won't give you any credit if you don't write it. And then you get this imaginary dotted line crossing x equals 1. Right, I don't know if you guys can see it, but it's this line right here at x equals 1. All right. So that helps us a little bit. To find everything else, let's convert this to exponential. All right, what would this be as an exponential equation? Our base is 2, right? 2 to the power of y, good, equals x minus 1, all right? And then once we have that, we can make a little table and then pick a couple values, right? You don't need that many points, right? I would probably pick just 0 and 1. You for sure need y equals 0 because that's going to get you the x-intercept. So when x is 0, we get 2 to the power of 0 equals x minus 1. So we get 1 equals x minus 1, and when you add 1 to both sides, you get 2. So that means your x-intercept is 2, 0. I'm going to plot that point now. All right, really you only need one more point after this one. Another easy number to pick, 1, right? I'm going to pick a y value of 1. And then I'll do that up here, right? Yeah. For the most part, yeah. I really don't think there's any other case where you wouldn't be able to, right? As long as you're plugging into the right spot, right? So plug it in for y and not x. Some people do that. So good, right? And then once you plug in 1, you can add 1 to both sides, and then you get 3 is x. So then you get an ordered pair 3, comma 1. That's enough points to plot your graph. Mm-hmm. We plugged in 0 for y. That went here. Hang on. There. Ordered pairs are always x, comma y. The y always goes second. Okay, what's our domain going to be in this case? 1 to infinity, with parentheses around them. Right? It's the x values, right? And you start at an x value of 1, and it's going to the right, which goes towards positive infinity. So 1, comma infinity. What's the range? Yeah, this one's negative infinity to infinity. Nice. That's all the information that I ask of you. That one might take a little bit more time, just because there's a lot of little parts to look out for. But really, it shouldn't be that hard of a process, right? Getting those numbers isn't particularly challenging. It's just you need to know what goes where, kind of thing. Something like 18. 18 is very similar to number 17 that we just did. It just has a different base, right? When you see ln, what's the base there? E, right? Log base e. So you would change it to a log base e. What if it just said log of x minus 2? What would the base there be? 10, right? So you would write log base 10. It would still be the same process, though. You would say y equals this, and then you would say 10 to the power of y is x minus 2. Or if it was ln, you would say e to the power of y is x minus 2. The only tricky thing with that one is that you would have to like approximate. Do you remember what e is approximately equal to? 2.7, right? So about 2.7. If you were to pick e to the first, let's say, and you were to pick a point like that, and you added 2 on both sides, you would get e plus 2 is x, which is about 2.7 plus 2. So what does that get you? 2.7 plus 2. 4.7. Right, so that's how you would approximate it. Again, it's no different, the process from this one versus the one that we just did. You just have a different base. Do I need to go over that one in more detail? Or do we think we're okay? Okay, good. Okay, on this page, I wanted to try number 20. What I will tell you guys, don't worry about any vertical shifting. So if you see a plus on the outside of your parentheses, don't worry about those. I really want you guys focusing mainly on something like 20. Something like 20 and the one that we just did. Yeah, that's why I was telling you to wait, right? Because you don't really need it. All right, so let's try this one. All right, same exact process though, right? So how would I find a horizontal asymptote? Good, parentheses equal to 0. 1 minus x equals 0. You can subtract 1 on both sides. You get negative x is negative 1. Divide by negative 1. And so you get x equals 1. If you wanted to just add x to both sides also, that's also fine, and you immediately get x is 1. Doesn't really matter. Oh, I hear you up there. Sorry. Vertical. Yeah, vertical asymptote. All right. To find everything else, let's convert it to exponential. Right? What would this equation be as an exponent? What's your base here? 3. So 3 to what? 3 to the power of y equals 1 minus x. Yeah, the log ones give you a vertical one. If I wrote horizontal in the previous one, I'm sorry. All right, it should be vertical. The horizontal ones show up in an exponential function. We'll do those towards the end. Everything about a log and an exponent are flipped. So if a log has a vertical, and exponent's going to have a horizontal. All right? But now that we converted it, let's make a little table of values. Again, you don't need that many, right? I would probably still just pick 0 and 1. 0 gets us the intercept. 1 gets us another point. All right, so this is going to be 3 to the power of 0 equals 1 minus x. So you get 1 equals 1 minus x. Subtract 1, we get 0 equals negative x. Bless you. And then when you divide by negative 1, you just get 0. X equals 0. So then your x-intercepts would just be 0, comma 0. Bless you. I'll plot those on the graph, right? I'm going to plot the x-intercepts, and I'm also going to plot the vertical asymptote. You don't particularly need to draw the vertical asymptote on your graph, but what I don't want to see is, let's say it crosses at any point. Like, you shouldn't have your graph cross that line at all. So I am going to check to make sure that it's at least close to this line. All right. Let's pick one more point. So let's pick 3 to the power of 1 equals 1 minus x, which is just 3. And so when you do 3 minus 1, it's 2 equals negative x. Divide by negative 1, you get x is negative 2. So negative 2 comma 1 is going to be somewhere right there. All right, where does it look like it's opening now? What direction? With respect to the asymptote. Right, you see that it's opening to the left. All right, so this one's reflected. It's reflected over this line, over the asymptote. All right, which is fine, right? Sometimes it will be reflected, but what does that mean about your domain? What's the domain going to be this time? Negative. Okay, it's pointing all the way to the left. If it's going forever and ever to the left, what are we approaching? Negative infinity. All the way up to, where's our asymptote? 1, right? Negative infinity, comma 1. All right, and then what's our range going to be? Negative infinity to infinity. Nobody should get that wrong. It's always going to be negative infinity to infinity. So let me zoom out. Okay. Questions on that one? All right. I can promise you 2 log graphs on your test. I think we covered everything that would be important to you guys. So yeah, I don't think there's any other cases that I missed, right? Everything on here would be fair game. Okay. Okay, I'm gonna try some of these. I know you don't see it on my page, but on your screen, in this little section, what are the directions for that, for 25 and 26? Rewrite it. Are you solving for anything here? No, so you're not going to get a number as your answer. You're simply just rewriting this, right? How would I rewrite this log equation as an exponential one? 18, good, to the negative 2 equals 1 over 324. Super, super easy questions. All right, you guys are going to want like 20 of those on the test. Right? It should be super easy. What about the next section? What do those directions say? Rewrite in logarithmic. Are we solving for anything? No, right? We're just rewriting it. So if you look at something like this one, right, how are you going to write number 29 in logarithmic form? Log with a base of 13 of 1, good, equals the exponent of 0. All right, so you're just reordering these things. It shouldn't be too bad. Do I need to explain those anymore? No, right? Should be pretty easy. All right, and now let's try 32. I think I have 2 more for you guys, and if you guys have more questions, I can go back. All right, so let's try 32, right? A classic exponential one. You guys had 2 of these on your quiz. How did we start these? Yeah, make a little table. You don't need to pick that many values. All right, 0 and 1 is fine. You could pick -1, 0, and 1, but most of you don't like dealing with the fractions, so I would just leave it at 0 and 1. We can get 2 to the power of 0 plus 1, which is 1 plus 1, so 2. All right, let's plot that point, 0, comma 2. And then when x is 1, I get 2 to the power of 1 plus 1 equals 2 plus 1, so 3. So 1, comma 3. And now we know that it's going to look something like that, right? This is an exponential growth. Graph is going to look something like that. Now let's find all of the properties of this graph as we did before. This one has a horizontal asymptote. What is it going to be? Y equals what? 1, right? Y equals 1. It's always y equals whatever plus or minus is there. All right, where's our y-intercept? 0, comma 2, right? We got it from our table. It's where x is 0. What's our domain? It's a super easy one. No one should miss it. Hello? Negative infinity to infinity, right? This is the super easy one, guys. Remember, in a log and exponential graph, the domain and range flip. If the range was negative infinity to infinity in a log, it's going to be that way in the domain of an exponential. What's your range here? You have to think a little bit more, but not quite, right? 1 to infinity. It's always the asymptote to infinity. 1, comma infinity. If it's facing downward, it would be negative infinity to 1. All right, I'm going to do one like that next. All right, questions on this one? All right, should be pretty straightforward. Again, you had one like that on your quiz. Feel free to review those. All right, and then I wanted to try one more with you guys. So let's try something like 33. I know it looks kind of weird. It's negative 3 to the power of x plus 1. Once again, make a little table. X, y. And then you can pick a couple numbers. 0 and 1 is perfectly fine. So this is going to be negative 3 to the power of 0 plus 1. Does that get you? What's 3 to the 0? 1, right? What's negative 1 plus 1? 0, right? They're opposites, so you would subtract. All right, and then plot a point right there. When x is 1, we get negative 2 to the 1. Oh, sorry, negative 3. Sorry. Negative 3 to the 1. Bless you. Plus 1. What does that get you? Negative 2. So 1, comma, negative 2. All right. Now let's find all of our qualities. What is the horizontal asymptote? Ooh, it's not an ordered pair. It's y. Okay, good. Y equals 1. Nice. Good. All right, so y equals 1 here. Good. So and then into this imaginary dotted line. All right, where are the points that we plotted? Are they above or below that line? Below that line, so that's going to tell you that it's going to open downwards. All right, it's going to point downwards. So we get y equals 1. And then the 2 points, we know it's going to be exponential growth facing down. What is our... whoa, hang on. Sorry. Y-intercept, sorry. 0, comma 0. All right, it's this point right here. What's our domain? Super easy. What's our range? This one got a lot of you on the quiz. Good. Negative infinity to the asymptote, so negative infinity to 1. It's facing down, so it's going to start at negative infinity. And then it's going to go up to 1. All right, I do believe I covered everything that'll be on your test. If you want to do any extra, that's just for your practice, right? So I would do that at home if you haven't, and then submit it by tomorrow morning. Any other questions? All right, good. I'll have this published today.